The purpose of this exercise is to familiarize students with Agilent MassHunter data acquisition software, which is used for controlling LC-DAD MS instrument. The software window consists of several panes: main menu and toolbar, system diagram, instrument actuals, real-time chromatogram and spectrum plot, method editor, and worklist editor. Depending on the current activities, these panes can be shown or hidden using the appropriate buttons to reduce the clutter. Before activating the modules, we need to set up their parameters. All analysis parameters are saved as method files and can be recalled at any time. The method is entered using the method editor pane, and now we will go through the most important parameters. The Properties tab allows user to enter a description of the method. ALS tab allows for setting of sample injection parameters. It consists of several sub-tabs. In ALS Setup tab, we can define injection type, so simple injection or advanced injector program, or injection with needle wash, that is most commonly used. In here we can enter the injection volume in microliter, for example 1 microliter. Note that in every field, by right-clicking, we can see the valid range, and additionally, by pressing F1, we can get help for the current pane. It should also indicate the position of vial with solvent that will be used for washing the outside of the needle after drawing the sample but before the injection. We typically use vial at position 1. Alternatively, we can use the flush port. Then the needle will be flushed by a flow of solvent placed into a designated reservoir. In ALS Option tab, we can change the injection speeds. They should be reduced if we have viscous samples. We can also offset the needle position for sample drawing. For example, if we have very small sample volumes or want to sample only the top layer of the vial. Finally, if vial or well bottom sensing option is checked, the needle will gently feel the bottom of the sample vial, then move up for 1 mm. This is extremely useful if we have very small sample volumes. Binary PAMP tab is used to set mobile phase related parameters. It also contains several sub-tabs. In Setup, we define starting flow, for example 1 ml per minute, and starting mobile phase composition, for example 70% A, 30% B. Additionally, we can inform software about the used solvents so that it can take their compressibility into account when pumping. And we can also add some user comments on composition, for example acid concentration. The stop time defines the interval after which the gradient will be ended, regardless on settings in the next tab. It is also used by detectors to define when to stop recording the signal. It is usually defined by gradient duration, but can be shortened if necessary. We will set, for example, 12 minutes. After the gradient is completed, the solvent ratio resets to the starting conditions, and system needs to re-equilibrate. The post time is used to define this re-equilibration period, which can be calculated or estimated from experiments. In our case, it is 3 minutes. Maximum pressure limit is set to the highest pressure the pump and column can withstand according to manufacturer's specifications. In our case, it is 600 bars. If the pressure exceeds this value, the system will automatically go into shutdown to prevent damage. Now in the Timetable tab, we can define the gradient. The gradient is entered in the form of time points. So we define a percentage of phase B at the beginning and end of ramps. For example, so in this case, the gradient will start from 30% B, increase to 70% in 7 minutes, then increase to 100% in additional 5 minutes. We can also keep it constant for, say, additional 1 minute, if we want. In Options tab, we can say the software to take into account the solvent's compressibility when pumping. We can also ask it to record mobile phase composition, flow, pressure, and so on, alongside the chromatograms, which can be useful for troubleshooting. And finally, we can set up the maximum flow gradient. In our case, it is 0.1 milliliter per minute. It means that if we set 1 milliliter per minute flow and turn the pump on, it will not immediately start pumping at 1 milliliter per minute, which would cause a pressure spike and could potentially disturb the stationary phase, but instead it will slowly, continuously increase it at the rate of 0.1 milliliter per minute. So it will take a total of 10 minutes to reach this defined flow. Column tab allows for setting up the thermostats. In our case, the left thermostat is used for mobile phase preheating and column heating, while the right one is used for thermostating the column effluent to the same temperature as detector cell, DAD, to prevent signal ripples. So we set the left temperature to 50 degrees and the right one to the same as detector cell. The ADSL tab is used to set up the diode array detector. In the Setup tab, we can define up to 8 signals to be monitored, and these signals can later be opened in data analysis software as signal A, signal B, signal C, and so on. For each signal, we can define wavelength and bandwidth. For example, 260 and 16 means the absorbance will be measured in 252 to 268 nanometers range. Additionally, we can define the reference signal wavelength and bandwidth. It should be some wavelength our sample is not known not to absorb it. For example, 550 nanometers with 100 nanometers bandwidth. The signal will be recorded until the pump stop time. Peak width or response time is related to the time constant, and it is used for short time nose smoothing. It should be close to the width at half height of the narrowest expected peak, and we know from experience that our peaks are about 6 seconds at the baseline, so we could use, for example, 2 seconds or 4 seconds. In addition to these discrete signals, the AD could also record a continuous spectrum within a defined wavelength range, for example, from 200 to 600 nanometers with 2 nanometer steps. In Options, we can indicate that the lamps need to be turned on before the analysis, as well as to ask the system to auto-balance the detector prior to each run. The ESI-QqQ tab is used to set up the MS parameters. The ion source to be used, in this case electrospray, is selected by ion source drop menu. Time filtering is equivalent to DAD's peak width. We can enter, for example, 3 seconds, that is 0.05 minutes. Time segments table is used to defining MS experiments to be run and their polarity. Additionally, we can choose whether the F length will actually be transferred to MS, because to reduce contamination, we can divert the effluent directly to waste whenever no peak of interest alludes. We can also select whether signals should be saved into a file. But note, MassHunter demands at least some MS signal to be recorded. So even if you're using only DAD, you have to check at least one segment with MS. If acquisition parameters, for example, modes, positive or negative, or scan types, are to be varied throughout the run, additional time segments can be added by right-clicking and selecting option Add Row. The first segment starts immediately, and for the other segments we need to define starting time. For example, from 50 minutes go into negative mode. The source panel is used for setting ion source parameters. Drying gas temperature, drying gas flow, for example 10 liters per minute, nebulizer pressure, for example 50 psi, and capillary voltage, for example 4 kilovolts. These values are selected based on mobile phase flow and composition. Generally, the higher flows and less volatile mobile phases require more intense desalination, so higher temperature, higher flow, higher pressure. In chromatogram and instruments panel, we can define additional signals that will be shown in the real-time plot. I usually monitor only the MS signal, either total ion chromatogram or base peak chromatogram, one or more UV signals, and pressure and mobile phase composition. Acquisition panel is the most complex, and its content depends on the scan type for the selected time segment. For example, if we select MS2 scan, we are asked to enter starting and ending M/Z, as well as fragmentary voltage and scan time. If we select MS2 sim, we only enter M/Z of the ion to be monitored, and of course fragmental voltage and scan time. If we select multiple reaction monitoring, we enter precursor ion and product ion M/Z values, as well as fragmental voltage, collision energy, and scan time. Note that if we select any of the scan types, so MS2 scan, product ion scan, precursor ion scan, neutral loss or neutral gain, only up to 4 scan segments will be allowed for any given time segment. For other modes, such as SIM or MRM, that limitation does not exist. After we completely set up the method, we can save it by file save as method. Now, if we need to run a single sample, we do it using a sample tab. Of this field, several have to be set. First, sample position indicate its coordinates in the autosampler tray. So the tray is organized like this. We have 2 plates with enumerated rows and columns. So we have position 1A1, 1A2, 1B3, and so on. Data file path and file name should also be indicated, and injection volume can be left as -1 if the value specified in the method is to be used, or we can override it by any other value. In addition to these fields, we can also enter additional comments in name, custom, and comment fields. When everything is set, and if the instrument is on and ready, we can start the run by selecting Run Interactive Sample, or by pressing F5. If we need to run more samples, we create a worklist. First, we open a worklist menu and select worklist run parameters. In this dialog, we define the operator's name, part of the method to be run, whether only acquisition or also data analysis, method path, so where to find the method to be used, or for example here, the data file path, so the directory that will store the data files, scripts. These are small macros or small programs to be run before the worklist, after the successful completion, and after any completion. For both, we select instrument standby. That will stop the pump, shut down column heating, DAD lamps, and MS nitrogen flow and heating after the instrument has finished the analysis, or if anything goes wrong. We do not use overlapped injection. If this option is enabled, both in method and in worklist, the next run will start before the current one is finished, to save some of the time. This clear sample selection after run option will simply uncheck the samples in the worklist when they are completed, making it easier to see which is the next sample. And wait time for ready. This is the maximum time to wait for system modules to get ready for the run. If it's exceeded, for example, if the heater cannot achieve the required temperature, the worklist will be terminated. When everything is set, we can enter the worklist. So we display the worklist table by clicking on W. A worklist table consists of numerous columns, but only several are absolutely necessary. We can actually configure them by right-clicking and selecting Show Hide Order Columns. So we need sample position, for example 1A1, method name, only from the directory we selected, and data file name, for example test. All the other fields can be shown or hidden as needed. The samples can be entered manually, one by one, by using add sample or insert sample, or they can be added in series by add or insert multiple samples. For example, we can add 5 samples that will be called sample 1 through 5. They will all be recorded using this scan method. And the positions will be from B1 to B5. And the samples are automatically added, and we can edit some details if we need it. Note that these parameters can also be directly pasted from, for example, Notepad or Excel. When everything is set, we can save the worklist, and if the instrument is on and ready, we can start the run by selecting Run Worklist, or simply by pressing F4. So in addition to method and worklist editor, we have several other important panels. In the real-time plot, we can see the current chromatogram and other signals, so we can right click and change. We can display binary pump flow, mobile phase composition. We can plot signals from detectors, so we can monitor what's happening in our system. Additionally, we can display UV or MS spectrum of the current element. In the system field, we actually have several fields. Instrument actuals can be used for displaying various diagnostic parameters. So for each module, we have a wide array of parameters to be selected, and they can be useful for diagnosing whether or why the system is not ready, if something is wrong, and so on. These two buttons, on and standby, are used to manually turn on or off all the modules at the same time. And here in the system diagram, we have some additional settings for each module. For example, for autosampler, we can configure the type of plates. For example, if we don't have a standard 45 vial plates, but we want to use 96 well plates, we can configure it here, and then the instrument will know how to position the autosampler correctly. We can also use this menu to turn on or off the tray illumination, so it's internal lighting in the autosampler. And here we can control the pump, so we can turn it on or off. We also can enter solvent levels. So this way we inform the software about the amount of mobile phase that is available for the analysis, and if the volume falls below the limit we enter, the system will not allow for analysis. It will stop. In the column section, we can turn the thermostat on, or we can also set it to be turned on at selected time. For DAD, we can turn lamps on, or we can balance our lamps, or do some performance testing. And for MS, we can turn it on or off. We can switch the flow to MS or to waste, and we can vent the instrument, which is the operation necessary before shutting the entire instrument down for some maintenance operation or for just prolonged idle.